like, oh, he's just talking about a smartphone.
Yeah, yeah.
We're just talking about this thing you guys would have said was godlike. No big deal.
Yeah.
One of my favorite of the epic rap battles of history is actually the Edison and Tesla.
Yes,
one,
I've seen
because,
that.
like, I didn't know about Tesla before that, so I
Good way
did
to learn
research and
about
it's like, well, what the heck?
All right, so questions?
So, the drawing thing,
Yes.
I was trying to mess with variables, and I realized if I wanted things to move or things to change, it would have to call it again. Is there a thing to force it to call
Yes.
paint?
Repaint. So we're going to
Okay.
talk about that shortly. Because you can't call paint because you don't have a graphics object to pass to it, but you can call repaint, and repaint basically will cause paint to be called eventually. So yeah, we're going to play with that. PA2 questions.
That might have been a PE2 question.
Could be.
Well, you said you finished the so.
Yeah.
The name for the class, the position of this class doesn't have, is that right?
I don't think it matters to me because I'm not going to interact with it.
Isn't the only one that matters the build index?
The build
class
index,
and the one method.
The word list class,
Oh, index utility.
because that's what index utility returns,
Yeah.
and index word list has to have a print method
Right.
to dump out the contents of your index. Most of the other stuff you could name it whatever, I think, and I don't think I'll notice. All right, well, we were playing with painting, and were we using draw stuff? I don't even remember. Yeah. So we had this set up, right? If you remember, we made a J-frame. It had a panel inside a J-panel that pops in there by default. And instead of using a J-panel, we renamed this thing to a My-panel, right? So our source code constructs it as a new My-panel, and we declare it as a My-panel. And then My-panel was a class that we created, but we said it extends J-panel, so all the stuff that's in J-panel is part of My-panel now. Okay, we inherited all of those methods and everything else that's in a J-panel, which means that our panel is basically a J-panel. Okay, but we also wrote a method called paint, and J-panels come with their own paint method, so we've overridden what that paint method is. So when J-panel's paint gets called, it does certain things. When My-panel's paint gets called, it does this thing. It draws a rectangle.
Wait, are you overriding it or extending it?
We're technically extending the class, but what we're doing is we're replacing
Okay.
the default method with our own method.
Without damaging the original.
The original's still there,
Yeah.
right, in the J-panel,
You're just not damaging it.
but we're not dealing with J-panel, we're dealing with My-panel. That's why we're working with a class extension, so that we can modify it, as opposed to going into the actual definition of a J-panel and breaking that. But there's an interesting point along those lines. So here's the My-panel. Let's put a button down here. Well, let's put an absolute layout first of all. And now let's put a button in here. And there's a button. And it just disappeared on us. And if we run our code, we've got the panel, we've got the rectangle. Where'd our button go? Right, and it's there. But if I resize, it disappears. If I happen to come over it, it pops up again. So it's popping up here because when you move over a button, it changes the appearance of it. It makes it look brighter, right, like you're pointing on it. And that's the only reason it's appearing. It's invisible right now, but the button is picking up that there's a mouse moving over it, and so it paints itself. But why isn't that button appearing originally? And if I make this a J panel, right, that will certainly do what we're hoping. But of course I lost my rectangle because I've got a J panel instead of a my panel. So here's the deal. Since we're extending a J panel, everything that a J panel is also a my panel, right? Except for the paint method. We are no longer using J panel's paint method, we're using this paint method, which does exactly two things. It draws a rectangle and it prints a message. Does it paint buttons that are supposed to be on the J panel? No. Does it fill in the background color? Well, it kind of looks like it's filled in, but that's just kind of lucky chance. It's not doing all the stuff that normally happens when you first expose a J panel or when you resize it, including things like drawing the components, okay, painting the buttons and stuff like that. Those things happen inside the original paint method. So what we'd really like to do is still use that original paint method, but then also draw a rectangle. So when we say something like class my panel extends J panel, you can kind of think of a hierarchy, and the way you draw this is like drawing stacks. It can go either way. But we think of this as a subclass, and we think of J panel as a superclass. And that may not always make linguistic sense, because in some sense this is an extension. It could be a J panel plus a bunch of other stuff, which kind of makes it seem like a superset of a J panel. But the terminology is that the J panel that we're extending is considered the superclass. Okay, so you know the keyword this, which basically refers to me. So an object can use the word this and it refers to that object. There's another keyword, which is super, which refers to the superclass. So what I can do in here is, before I draw the rectangle, I can say super.paint G. Super is the name of the superclass, which is J panel, so this is calling the paint method that's part of J panel, the original paint method. Therefore, I pass it this graphics object G, which I've got because it was passed to my paint method. But this will execute all the code that normally a J panel executes when it needs to paint itself, so when you resize it or things like that. And then after doing that, I'm going to fill a rectangle. And so if we run this, we get exactly what we were hoping for. And it's rock solid. And if we happen to do this in the other order, what's going to happen? We fill a rectangle and then we call super paint. Our rectangle gets overwritten. Why? Because part of the paint method for a J panel clears the palette before it starts drawing, so it's going to make our rectangle go away. All right, so we're building a small repertoire of things that we're going to need to do in order to do painting. And repaint's going to be the last piece. So let's tie this in with an event. Okay, let's tie this together with mouse actions. So I'm going to go into our J-frame, and here's our my panel. And I'm going to right click on it and say add event handler, and we'll add a mouse moved handler. So we're going to come in here when we move the mouse over that panel. And what I'd like to do is draw that rectangle right where the mouse is. Instead of just drawing it at 50-50, I'd like to draw it at whatever the x and y coordinates of the mouse are. And we can find those coordinates from the argument using the getX and getY methods. So we've got the x and y positions we want to use, and now we want to draw a rectangle there. And that's not clear how to do that because we can't say fill rectangle inside this piece of code. This is not a paint method. This is a mouse motion listener. The only place we can really say fill a rectangle is down here inside this paint method. So we've got to somehow, in here when the mouse event happens, set things up so that when the paint method gets called, it'll fill a rectangle in the correct position. Okay, so this is back to the idea of a stateful system. We're going to change the state. We're going to somehow set things up so that when this code executes, it fills a rectangle at whatever XY position the mouse was at. So how do we do that?
You can put a variable in paint and have it that it paint method. So
Cool.
It creates a paint. No, it creates a my paint.
Okay.
And you can have it edit my paint. Yes.
All right, so we'll have a last x and a last y in here. And I'm going to right click on this, and I'm going to say source, and I'm going to say generate getters and setters. And I'm going to do the same thing for last y. And you've got options. You can do just getters or just setters and so on and so forth. But I'll just take all of them. So now I have access to these things. And I should have declared last x and last y private, right? And then I've got access to them through here. So over here, I'm going to do the following. So,
You call it content pane.
say what?
You call it content pane.
Content pane. Alright, so I call a set last x method in that my panel, and I give it the value I want to save. And I do the same thing for y. And so we're almost done. We're at the point of your question now. So if I run this, oh, we forgot to use those though. So over here in the paint method, instead of painting at 30-30, we'll paint at last x, last y. So it started off at 0, 0, and I can move my mouse around here, but nothing's happening. But in fact, if I were to resize my window, my rectangle is where my mouse was. So the problem that's happening here is that we're saying when you paint the My panel, here's what I want you to do. But there's no reason that simply having a mouse event is going to cause that panel to be repainted. Now if you resize it, it'll repaint. If you occlude it and then expose it, it'll repaint. If something happens that the system knows is changing something in there, it will repaint. But by itself, all we've done is set things up so that when it gets painted, it'll display the rectangle. But we need to tell it, hey, go ahead and repaint that panel. And we can do that with the repaint method. So we call repaint, and that registers a request to call paint. It does not call paint right away. it makes a request with the system that says, hey, when you have a chance, you're not too busy, can you repaint that panel for me? Okay, now it's going to look like it's immediate to us, but in reality you're just sort of putting that request out there, and other things can request that things be painted as well. We can't call paint from here because we don't have a graphics object, right? So the best we can do is call repaint. Eventually the system, in response to that, will call paint. It'll pass it a graphics object. We'll pick up the last XY position that we just saved, and we'll fill a rectangle there. So if we run this, we've got our rectangle following our mouse around. And when I get on the button's picking up the mouse events, so the panel's not seeing those, so it'll stop following me until we get back to the panel. So rehash all of this. How do we do graphics? How do we draw lines and rectangles and make things appear in a window? So first step, extend your J panel, or whatever object you're drawing on. Usually it's a J panel, but it could be anything. So extend your J panel, okay, and then override paint. Throw the argument in there. And then elsewhere, set up things. That's what we call state. So paint does the right thing. And then call repaint. So it's really 4 steps. The preparation is extend the component that you're going to do your drawing on so that you can make your own paint method. And inside your paint method, usually you want to call your superclass paint to do all the stuff it used to do, but then do your own thing. And then when you want painting to occur, set things up so that the paint method will do the right thing and call repaint. Now, if we don't call this superclass paint, we can get some kind of cool behavior where it does this kind of thing. Right? So that could be a feature or a bug. What's happening, the superclass paint resets the whole panel, right? It draws everything in the background color, which makes our previous rectangle disappear, and then our paint draws a rectangle. If we're not calling that, then everything that's drawn on there is still just visible. But this isn't really the right way to do this kind of thing. It's just using an artifact of not doing things correctly. But it's a kind of cool artifact. And if you resize, it goes away. And you can see if you're faster than the code. So can you get gaps in there? More cheap video games. Okay, but usually we're going to want to call paint. All right, so we started talking about color. So questions on this so far? So we started talking about color, right? And we described red, green, blue. Did we get through that? So an Rgb color model, so each of these goes from 0 to 255.
Yep.
Okay, and then graphics class has a method called setColor. And there's some constants, some statics that are defined like color.red and so on. Or we can create our own color. We could say new color 255 0 0. And that says full intensity on the red beam, 0 intensity on the green and blue. This will basically set the color for whatever gets drawn next to be red. And so if we run this, same thing, but we got a red square and a button that pops up sometimes. And you can try to cover it up. So in yesterday's class, someone had the idea, what if we set the color based on the XY position? That sounds fun. But let's do it modulo 256, because if you put a value in bigger than 255, you'll throw an exception. And it keeps running, but... So we can just do red and green. And so we've got colorful boxes.
Could make blue some of it too.
You could throw some blue in or something. Or you could use the mouse wheel, change the blue color. So it's goofy and it's silly, but it's fun to play with, right? But it's also, it's a platform in which you can start experimenting, right? So, and it's 2 lines of code, right? Set color and fill a rectangle. We don't need to be printing out, calling paint all the time. So yeah, you want to play with the mouse wheel. You can like put a mouse listener on there and pick up the scroll wheel position and do something with that, or change the size of the rectangle based on how you scroll the mouse, or put in key codes for turning up and down the red, green, and blue guns. And it's more fun to play with graphical output than text output sometimes. So it's a kind of launching point, but this is basically, right, what you're going to do any time that you're doing this kind of drawing, right? Set things up and then actually have your paint method do the painting and call repaint. And I think for swing, technically, they tell you that you should be using paint component instead of just paint, but everything works the same. And I'm just going to use paint. All right, questions, comments?
Is there like, I don't know, a negative side to having to call paint every frame? Thinking if you wanted to make like a video game or something, animations, you have to call every frame.
Yeah, you have to repaint it every time you want to change the display. Sure, I mean, everything has a penalty. And a good video card will do lots of animation work for you. It'll do its own rendering of polygons, for example, and hidden surface removal and things like that. And you probably would not do it with this kind of stuff, right? But for learning and experimenting, right? The more that you're doing things by hand, I think the better the learning experience. But this is what makes GPUs so powerful or so useful, right? Is that they do all these things in hardware. And all of these things, rendering polygons and filling and texturing and shadowing and hidden surfaces and all that kind of stuff, it's all done with matrices, right? It's all linear algebra. So if you can crunch matrices very efficiently, you can do efficient graphics, right? And that's a big thing that GPUs do, and that's one of the reasons GPUs are one of the more popular ways to build supercomputers now, because they do really fast math, they do fast matrix operations, they're parallel, they're cheap, right? You can build a stack of GPU cores. And NVIDIA for years has had a programming environment called CUDA that they make freely available, and lets you basically use their graphics cards as processors. And some of the faster supercomputers for years have been built out of GPUs. So it's kind of a cool technology to dig into. A really good service learning project. But don't change your SLP now. All right. Well, let's talk about some math. So you got a tic-tac-toe board. And let's say this thing is sitting in its own J panel, or my panel. And remember, on your J frame, you're going to have buttons, and you may have a message box, and so on. But you can create a separate J panel, right, or a my panel, just to hold the playing field. And if you do that, and you paint in here, and you pick up mouse events in here, it saves you from the possibility of what if someone tries to make a move by clicking right here. Your code's not even going to see it, right? It's only going to pick up clicks inside here. And so the next question is, a person clicks somewhere, you get X and Y coordinates. You don't really care about the X and Y coordinates. What you really care about is the row column coordinates, right? So this is 0, 0, and so on. Oh, they're coming for us. Right, you want to know what was the row column they clicked in. So let me start with a simplifying proposition. So this is X and this is Y. Suppose X goes from 0 to 299 and Y goes from 0 to 299. So this is a 300 by 300 playing field. And they've clicked at some point X comma Y. If you know the X coordinates, how can you figure out what column they clicked in?
Divided by 3 by the length by.
Okay, divide the length by 3. So let's say 300 over 3 is 100. Divide the X coordinate by 100 and take the integer value. So if they click anywhere from 0 to 99, you're going to get row 0 or column 0.
Does it always floor when you do it like that?
Yeah, it does if it's
Okay.
positive.
Great.
If they click from 100 to 199, you're going to get column equal 1. And if they click from 200 to 299, you're going to get column equal 2.
If the window is resizable, wouldn't you want to do, instead of using heart 100, wouldn't you want to do the total width divided by 3 instead of 100?
Good. So take X divided by 1/3 of the width, right? Or 3 times X over the width, and that'll give you your column. So quick math, how do we do row?
Why?
Instead of X.
And the height.
Oh, dang.
Perfect. So there's a pair of simple functions that will get you row and column from X and Y. So what do? Throw that in a method. All right, have a method, you pass X, Y, it gives you back row and column, or a pair of methods for row and column, or something like that. Because you're going to want to do this a fair amount, maybe. So they click somewhere, and now you know which box they clicked in. Good. Now the other direction, if you want to draw a circle in, say, box 1, 2, you got to find the coordinates of this box, and that's just multiplication instead of division, right? So which coordinate do we want? Maybe the upper left. So the row corresponds to y, the column corresponds to x. So the coordinates might be 2 times, and if it's 300 across, right, 2 times 100, comma, 1 times 100. Or do 2 times width over 3, 1 times height over 3. But that will let you find the upper left corner of whatever box you're interested in. Then if you want to draw a circle, you just displace from there a certain amount and draw a circle. If you want to draw an X, you displace and do a pair of diagonals, and you got to figure out the coordinates of these points. But get a sheet of graph paper and visualize a 100 by 100 rectangle, or maybe something coarser, and draw your X and figure out where the coordinates are when it's going to be fixed. So have some offsets and draw some X's, and if they're lopsided, change them. So this kind of transformation is very typical in graphics processing. What we're doing basically is changing coordinate systems. Here we have a really, really simplified coordinate system from 0 to 2 in X, from 0 to 2 in Y. But the paint method has a system of coordinates from 0 to 299 in each direction, and we're just doing a transformation. In this case, it's just a scaling transformation, so it's a multiplication. But more generally, if you wanted to plot a sine wave, from -12 to 12 and -1.5 to 1.5, and you're doing this inside a pane that goes from, say, 0 to 800 and 0 to 300, you got to do a few more steps to do the scaling and transformation, but it's the same thing. We're just going from one coordinate system centered here to a different system centered here. So you multiply or divide to shrink or expand the scale, and you can add or subtract from each one to shift your origin one way or the other. I'm wondering if it's worth doing this. We can do it another day. Keep going. I can't tell if I'm losing people or if it's Thursday sunny or if it's if you're blissing out on the marvelous swing. Let's talk about state a little. So we've said that when you're playing this game, the user clicks somewhere, you do your math, you discover that they clicked in row 0, column 0. And you have to do different things depending on, is the game in progress, has the game ended, is there already a mark here, and so on and so forth, right? So a big part of the state of the system is the game playing, has it ended, that kind of stuff. Those are just variables you're going to set and clear. You know, when the person hits the start button, you're going to set a flag that says the game's in progress. When you detect somebody's won, you're going to clear that flag so the game's no longer in progress. But a big part of the state is going to be the current condition of the board, the playing field. And you're going to need to know throughout your code, is this square open, is there an X, or is there an O? So how could you store that kind of state information?
Each square could be an object.
Square could be an object. What kind of object?
A square.
A square.
You have to make a custom, I think. Right?
Okay.
Start off with maybe rectangle, defining where it is,
Okay.
and then it's state.
Okay. What sort of state information is there?
Three states.
Empty
Which are
X or O.
empty X or O. What can we use to store empty X or O?
Integer.
integer,
Character.
character. I like character. It's going to be less secret codings.
You can also store JSONs.
Or you could do that. So here's one way to store your state. Two-dimensional array of characters, 3 by 3.
That's a better way of doing it.
Now the user clicks at some square RC. This tells you what the current mark is in that square on the board. If it's not empty, you can give an error message. If it is empty, you can set it to whatever mark you're trying to put there, and you've updated your state now. Now flip over to the output side when you're trying to draw your playing field. You're in your paint method, right? You don't get to draw when the user clicks or when the computer moves. You only draw in your paint method. And in your paint method, you want to draw something like this. Right? How's your paint method going to figure out what it has to draw? It knows it's got to draw the 4 lines to make the playing field. How's your paint method going to know whether it has to draw X's or O's?
For loop and case statements.
Okay,
Switch statements.
what are you going to look at in that loop? Yeah, the two-dimensional array of board information, right? Your state variable board. So if paint has access to that array for row equals 0 to 2, for column equals 0 to 2, look at character board bracket row bracket column, and if it's an X, draw an X at row column. If it's an O, draw an O at row column. Otherwise,
Oh.
don't draw anything.
They're just characters, you could just say print.
You could just print them, but that's a little hard to make it look nice. It's easier to control if you draw them yourselves, but if you want to say draw a string, you can do that. But you gotta mess around with the font, and it's going to kill your ability to resize, probably. But it's an option. I had one person, they used the Enterprise in a Klingon cruiser instead of an X and an O. That worked well. Because you can draw images in graphics class also. So lots of state information, right? Has somebody won the game? That's going to be a variable. Each time somebody moves, your code's going to have to check to see if there's 3 marks that are in a line or in a diagonal. And in your paint method, you're going to need to know, should I be drawing a line somewhere? Right? So you can check it in the paint method, or every time somebody moves, you can update a state variable that says somebody won, and you can store where that winning line should be drawn, and your paint method can check that flag, and if the flag is set, it can say, okay, I need to draw a line from here to here, and it draws the line in. Okay, but you're going to keep coming back again and again to this idea that you're setting things up, right? And your paint method's going to respond to what you've set up. And I'm going to suggest that you try not to fight that idea, right? Because if you're coming from a C background, the natural thing is, I've got my code, I just found that somebody won the game, I want to draw that line. How do I draw the line? Why can't I draw it, right? But if you keep coming back to this idea of, okay, leave some breadcrumbs around so that when paint runs, it knows to draw a line, right? That'll get you over that sort of mental bump.
For
like what?
Like,
Like a linked list class or something?
like a hash map or something like that.
Yeah, you can do that. Just don't use the Tic-Tac-Toe class.
Of course there's a
I'm sure there is.
Makes you think like, I bet you someone found it, if that was a thing in Java, somebody's probably already found a really obscure way to use it.
Yeah, yeah.
Um,
Lost it? Okay.
It's good. Imagining about how you would do chess in this sort of way. It'd be
Would it be very different?
not really, but also kind of, because each piece has its own behavior too.
Mm-hmm.
But that shouldn't be terribly difficult to figure out.
So this is one of those things where I wave my hand and I say that's just code, right?
Yeah.
Doesn't mean it's easy, but as far as making an interface and rendering it and that kind of stuff, right? It's going to be exactly the same.
Yeah, that stuff is the same.
Yeah. But if you wanted to actually do a tic-tac-toe game, right, you need to modify the notion of a legal move, right? So we could still have the computer make random moves, but it's more complex to know if they're legal, a little more complex, right? It's different for each move. But again, you could have an 8x8 array of characters that stores, you know, an uppercase or lowercase designation of each character, tells you what that piece is, and when anybody moves, you got to know if it's legal. You've got to know if something has happened, right? Like another piece is going to disappear because it's been captured, and you update your state array and take turns moving, same as here. Got to know when the game's over. It's probably not all that much harder, other than the small detail of the AI part.
Yeah.
If you wanted to actually play a good game.
So I'm thinking, just from like object-oriented stuff, when is it a good call to start making a bunch of objects rather than having a huge controller manage everything?
That's a good question.
That's something that will separate.
Yeah, that's a really good question.
Like just was a good example. Do you want to have each piece be an object, or do you want to have master controller with an array?
And you might, right? So for tic-tac-toe, you probably don't want an array of 9 objects because these marks don't really do anything. They don't change, they don't move around, they appear and they get tallied, right? But for something like chess, you may actually want to do that. So you would actually have an array of 64 objects, and then you could call that object's move method if you could generalize how each piece moves, right? Like a bishop, you can't just say move 3 squares. You got to know which direction. But yeah, that might make sense. It's a cool idea. All right, so let's talk about next week because we got a minute left. So I will post Lab 3, and Lab 3 is going to be built on the idea of threads. So Monday I want to start talking about threads and multi-threaded execution, so running parallel processes. And then I'm not sure. We're either going to go pretty deep into that and talk about full-on parallelism, which is a whole separate topic, or I'm going to back away from this stuff while you're working on PA3, and we're going to start talking more about data structures. So we'll go back and we'll talk about balancing trees and things like that, and we'll look at some of the other classes that are available for doing things like linked lists and hash maps and stuff like that, and sort of take a break from going into more language elements for a while you do PA3 and Lab 3. So we'll figure it out over the weekend. All right, so I'll be in here tomorrow at 11. If you're having any sorts of issues, come in and we can work on it in here. Otherwise, I'll see you next week.